Dear student, today I am going to take the topic of sparse matrix. Okay, so first I am going to tell about what is sparse matrix. Before entering into the sparse matrix, what is matrix? Matrix is a it's a kind of array which is represented in the form of row and column. Okay, so for example, in the if the matrix consists of m row and n column, then it will be represented in the form of m by n matrix. So this is the kind of representation. So the numbers or elements are arranged in the form of horizontal or vertical line of entries. Okay, then this is a one of the example for the matrix. Here there are three. This is a horizontal line. So this horizontal line or horizontal A11, A12, A13. So this is called as a this three element represented in the form of horizontal way. So this is called as a row. The column means vertical form. So A13, A23, A33. So this is represented in the form of vertical one. So this is called as a column representation. Okay. So here there are 9 elements. So it is represented in the form of 3 by 3 a matrix. Okay, so this is the one of the example for the matrix. Okay, so now we move to the what is sparse matrix. Sparse matrix means the matrix which consists of a highest number of 0 compared to non-zero element. So this is called as a sparse matrix, or otherwise we can say that the matrix consists of a 0 element. Most of the elements are 0. Some of the elements are non-zero element. So this type of matrix is called as a sparse matrix. Mostly the sparse matrix consists of a 0 element. Highest number of 0 element or greater than the 0 element is greater than the non-zero elements. Okay. So then why we use the here this is the question, then why we use the sparse matrix. So already the matrix is available, why we use the sparse matrix? Because these are the three reasons. Because the first one is the storage means if we use the matrix mean it take a high amount of storage. For example, the 0 element is greater than non-zero element, so it take a more storage. So that's why we use the sparse matrix. The another one, computing time. Most of the elements are 0, so if you traverse from one element to another element, it take a highest amount of time. Okay, then it save computing time by logically designing data structure traversing non-zero element. So the computing time is high. Okay, then representation of a sparse matrix. So the sparse matrix is represented in the two form. One is a array representation, the another one is a linked list representation. Okay, so the array representation means, what is the array representation? So it will be represented in the form of 2D. 2D, then here 0 in the matrix are no use. So storing 0 with non-zero element is wastage of memory. That means many elements, that means the greater number of elements are highest number of elements are stored in the form of 0. So that's why if you use the each and every 0, it take a huge number of elements. So that's why we use the sparse matrix. So in array it will be represented in the form of triplets. Here the triplets means three. Okay, the row, column and value. So it is first we represent the index of row, then the column index, then the value. For example, here this is the row, column and value, it is represented. So here this is the one of the example for the sparse matrix. Most of the elements are belongs to the 0 element. Now here only 7 element, 1 2 3 4 5 6 7. So there are 7 elements belongs to non-zero element. So the remaining 13 elements are 0 element. So here we should concentrate only for the non-zero element. We ignore the 0 element, because if you take all the 0, it store it take a huge amount of workspace, and also it take a huge amount of computing time, etc. So that's why we take only non-zero element. Okay, here it is represented. For example, now I explain. So for now we move to the first row. Here the first row is 4. So the 0 is the first row, index value 0, then the 1 is the column value. Okay, we take the 0 comma 1, then the value is 4. Here it will be represented 0 1 4. Okay, same as the next value 5. So the row value is equal to 0 and the column value is equal to 3 and the value is equal to 5. So it is represented like this form. So the remaining all the 7 elements are represented in this form. Okay, so this is called as a totally 5 rows and 4 columns, 20 element. Only 7 columns, 7 values are belongs to non-zero element. So we store only 7 element. So that's why it take a very less amount of memory. Okay, the computation time also reduced. Okay. Then already I told you triplet. So now it will be represented in the theoretical format. Okay, so here the 8 element for this is the one of the example. 8 element, take a 8 element means 3, then 24, 3 means triplets, row, column, row index, column index, and then another one value. So totally 24 memory space. Suppose if we use the sparse matrix, it will take the 8 into 8 to 64 memory space. So that's why we use the table structure, array table structure. Okay, so next we move to the linked list representation. The linked list representation is similar to slightly different from array matrix. Here it will consist of a 4 field. 4 field means first the row index, then the column index, value. After that the next node is also exist in the linked list representation. So same as the previous one, but here the pointer to the next node is available. One non-zero element is linked to the another non-zero element. Okay, then so this is the one of the example for the sparse matrix. Here there are 1 2 3 4 5, the 5 elements are non-zero element, remaining 11 element belongs to 0 element. Okay, now we concentrate only for non-zero element. So first we take the 1. So this one, what is the row value is equal to 0, then column value is equal to 2, then the value is equal to 1. So this is the representation 0 to 1. Okay, next it connect what is the next 0 value? So 3. So row value is equal to 1, column value is equal to 0, 3. So it will be linked with the next value. Likewise the remaining values are linked with each other. So final one is a null, because it will not attached with any other value. Okay, so this is the linked list representation. Okay, so these are the theoretical form of explanation about the linked list representation. Okay, Dear student, today I take the topic of the sparse matrix. If you have any kind of doubt, please kindly give your questions in the comment section. I will clear your doubt. Thank you, student.